Welcome back to the Canadian Electrical Code Masterclass series. This is episode 4, Sub-Panel Grounding and Bounding with 2024 Code Rules. If you're wiring a sub-panel in a house, basement, shop, or garage, this episode will save you from major inspection failures. Section 1, Main Panel versus Sub-Panel. In the main service, the neutral and ground bound together. In a sub-panel, the neutral must flow fully isolated. This stops parallel path and prevents shock on metal parts. Rule OESC 10-208. Neutrals isolated except at service disconnect. The neutral bar must not touch the metal can. Remove the bonding screw or bonding strap. Grounds must be on a completely separate bar bonded to the panel. Refer to OESC Rule 10-204. All metals enclosures must be bounded. All feeder conduits must carry an equipment bonding conductor, EBC. For aluminum, SCR, or TEC, ensure bonding wire included. Neutral is size per Rule 4-022. Bound wire per Table 16. Ground electrode conductor per Rule 10-700. Section 5, GEC and electrode systems. Ground rods, ground plates, water pipe bonding. Structural steel bonding. Tie this back to service grounding, not sub-panel grounding. Common mistakes: bonding screw left in, neutral bars touching enclosure, no EBC in conduit feeds, missing grounds and neutral, no isolated neutral lugs. Welcome back to Grounding and Bounding Masterclass series. Today in episode 4, we're breaking down one of the most confusing parts of the OESC. Ground rod versus ground plates, and when you're required to use each one under the 2024 code. We'll cover code rules, conductor size, depth, connection methods, and the real-world difference between the two. A ground rod is simply a vertical grounding electrode. It gives the surface a reference point to earth, helps stabilize voltage, and reduce lightning impact. But it does not trip breakers. Under OESC 2024, your ground rod must be at least 10 feet, 3 meters long, half-inch steel or copper clad, driven to full depth unless rock stops it, minimum 600 millimeters, 2 feet above grade for the conductor clamp. The GC can be copper, aluminum, or copper clad depending on location exposure. What ground plate does. A ground plate replaces the rod when driven. When driving a rod is not practical, such as rocky terrain or bedrock. OESC Rule 10-802A and B allows a ground plate as an alternative electrode. A complement ground plate must be minimum 0.2 meters square surface area, minimum 6 millimeters thick, buried at least 600 millimeters below grade, copper or galvanized steel depending on corrosion. The plates create surface area with earth that makes up for not being able to drive a rod. Which one is better and when to use it? In normal soil, a 10-foot rod is faster, cheaper, and code approved. But in certain locations, northern Canada, rock, ledge, a rod is useless because you can't get proper contact. Use a ground rod when soil is soft. You can drive the full length, standard residential, or light commercial. Use a ground plate when rock/bedrock stops rod penetration, rod depth is impossible, ESA or inspector prefers a surface area contact. You need an alternative electrode. Under OESC 2024 Rule 10-806, your grounding electrode conductor size depends on service conductor size. Example, 100 amp service, number 8 copper. 200 amp service, number 6 copper. 400 amp service, number 4 copper. Aluminum must be upsized and cannot be used where exposed to physical damage. Connections must be made with a listed approved clamp, weather resistant, accessible unless buried, copper to copper preferred. Never put the GC under a lug not rated for grounding. Never use a self-screw lug meant for feeders. So remember this. Ground rod, vertical electrode, 10 feet long. Use where soil allows full depth. Ground plate, alternative electrode, 0.2 meters minimum surface area. Use where driving a rod is not possible. And your GEC only creates the reference to earth. Bonding is what clears the fault. This is your episode 4 breakdown. Stay safe, stay grounded, and see you in episode 5. Also, don't forget to like, share, and subscribe to the channel. You can also become a member of the channel. And I'll catch you guys on the next live stream. Welcome back to the Grounding and Bounding Masterclass series. Today in episode 4, we're breaking down one of the most confusing parts of OESC. Ground rod versus ground plate, and when you're required to use each one under the OESC 2024. We'll cover code rules, conductor size, depth, connection methods, and the real world difference between the two. A ground rod is simply a vertical grounding electrode. It gives the service a different point to earth, helps stabilize voltage, and reduce lightning impact, but it does not trip breakers. Under the OESC 2024, your ground rod must be at least 10 feet, 3 meters long, half-inch steel or copper clad, driven to the full depth unless rocks stops it. Minimum 600 meters, 2 feet above grade for the conductor clamp. The GEC can be copper, aluminum, or copper clad depending on location exposure. A ground plate replaces the rod when driven. A rod is not practical, such as rocky terrain or bedrock. OESC Rule 10-802A and B allows a ground plate as an alternative electrode. A complement ground plate must be minimum 0.2 meters square surface area, minimum 6 meters thick, buried at least 6 millimeters below grade, copper or galvanized steel depending on corrosion. The plates create surface area with earth that makes up for not being able to drive a rod. In normal soil, a 10-foot rod is faster, cheaper, and code approved, but in certain locations, northern Canada, rock, ledge, a rod is useless because you can't get proper contact. Use a ground rod when soil is soft. You can drive the full length, standard residential or light commercial. Use a ground plate when bedrock stops. Rod penetration, rod depth is impossible. ESCR inspectors prefer surface area contact. You need an alternative electrode. Under OESC 2024 Rule 10-806, your grounding electrode conductor size depends on service conductor size. Example, 100 amp service, number 8, copper. 200 amp service, number 6, copper. 400 amp service, number 4, copper. Aluminum must be upsized and cannot be used when exposed to physical damage. How GC bounds to rod or plate. Connections must be made with a listed approved clamp, weather resistant, accessible unless buried, copper to copper preferred. Never put the GC under a lug not ready for grounding. Never use a set screw lug meant for feeders. So remember this: ground rod, vertical electrode, 10 feet long. Use where soil allows full depth. Ground plate alternative electrode, 0.2 meters square, minimum surface area. Use where driven a rod is not possible. And your GC only creates the reference to earth. Bonding is what clears the fault. So as you can see, these are the rules that align with today's video. And it says here again, perfect for rocky soil. And as you can see here, it says grounding electrode conduct to ground rod, ground plate electrode installation. These are the diagrams, main service bonding jumper. As you can see, there's a perfect diagram of what I've been talking about. So when it comes to ground rod versus ground plates, what do I prefer? I prefer ground plates. Reason being is with the ground rod, you have to drive it into the ground. And again, when it comes to underground, you do not know what's buried underneath the ground. For that reason, you possibly have to have the ground scanned. You don't want to drive a ground rod into the floor and not knowing what is underneath the surface. You can hit conduit, existing wire, whatever it may be that was buried before underneath the ground. So it becomes very dangerous when it comes to ground rod. So for that reason, ground plates I prefer. You can dig. You have to dig for the ground plate to bury your ground plate, opposed to ground rods. You drive it into the ground using hammer. I've seen some people use tools to drive it into the ground. So this is the reason why I like to use ground plates, and I'm sure many other electricians approve of ground plates also. But again, it's not up to us, it's up to the code book. It's up to what is required by code wherever you are working in that situation. So for all those who are tuned in into today's live stream, don't forget to give it a thumbs up. Don't forget to smash that like button. Don't forget to make sure your notification is turned to all. That way you can receive my regular videos, my live streams, and my shorts that I post. You can also share the video to someone else. And I will catch you guys on the next live stream. Under OESC 2024, your ground rod needs to be 10 feet and your ground plate needs to be 0.2 meters square of copper or 0.25 meter of steel. They do not replace bonding. Grounding stabilize voltage. Full breakdown is on my live stream replay. On the line side of the 400 amp disconnect, this is where all utility conductors enter. Under OESC 2024, Rule 6-300. The service conductors must be sized accordingly and physically protected from damage. You'll normally see a 350/500 MCM aluminum, depending on distance. Separate neutral conductors, full-size bonding conductors. Everything on the line side is unprotected, so treat it like it's live, even when it's not touching these. Wrong is not a second chance situation. On the load side, once you exit the disconnect, your conductors are now protected by the rating of the disconnect. In this case, 400 amps. This is where you feed the 400 amp main panel or split the service into two 200 amp panels using a splitter. Under OESC Rule 6-112, your disconnect must be grouped, readily accessible, and serviceable. Bonding is not grounding. Bonding is connecting all metal parts together so a fault clears quickly. This falls under OESC Rule 10-606 and 10-6112. Bonding the metal raceways, bond the disconnect enclosure, bond the neutral at one point only, the main bonding point. Never rebound in a sub-panel. When the bonding screw is in the wrong place, your panel becomes energized. This is how houses burn down. Welcome to episode 2 of the Grounding and Bounding series. Today we're breaking down the grounding electrode conductors, also known as the GEC. One of the most misunderstood parts of electrical work. After this video, you will know exactly where it goes, how to size it, and how to install rods or plates correctly on the OESC 2024. The GEC is the conductor that connects your service to the earth using grounding electrodes. It does not trip breakers. It stabilizes voltage, reduces sliding impact, and connects your service to the earth reference point. Ground rods 5/8 in diameter are usually 10 feet long.
must be fully buried, copper or listed steel. Ground plate, minimum 24 times 24, buried 600 mils or 24 inches deep. Must be labeled direct burial. If soil is rocky or rod depth cannot be achieved, grounding plate is used. For a 100 amp or 200 amp service, most installs use number 6 copper rod for rods or plates. For 400 amps, many jurisdiction requires number 4. Always check table number 16 in the OESC for the exact sizing. Keep GAC as straight as possible. Protect where exposed. No sharp bends. Must be accessible for inspection. Use copper direct burial clamps. Never land GEC on your downstream panel. It only belongs at the first means of disconnect. Bonding clears faults. Grounding stabilized voltage. 2 different systems, 1 safe installation. That's your full breakdown of grounding electrode conductors under OESC 2024. If you want episode 3 on neutral isolation next, drop a comment and let me know. Stay safe, stay grounded. Welcome to episode 2 of the Grounding and Bounding series. Today we're breaking down the grounding electrode conductors, also known as the GEC. One of the most misunderstood parts of electrical work. After this video, you will know exactly where it goes, how to size it, and how to install rods or plates correctly on the OESC 2024. The GEC is the conductor that connects your service to the earth using grounding electrodes. It does not trip breakers. It stabilizes voltage, reduces sliding impact, and connects your service to the earth reference point. Ground rods 5/8 in diameter are usually 10 feet long, must be fully buried, copper or listed steel. Ground plate, minimum 24 times 24, buried 600 mils or 24 inches deep. Must be labeled direct burial. If soil is rocky or rod depth cannot be achieved, grounding plate is used. For a 100 amp or 200 amp service, most installs use number 6 copper rod for rods or plates. For 400 amps, many jurisdiction requires number 4. Always check table number 16 in the OESC for the exact sizing. Keep GAC as straight as possible. Protect where exposed. No sharp bends. Must be accessible for inspection. Use copper direct burial clamps. Never land GEC on your downstream panel. It only belongs at the first means of disconnect. Bonding clears faults. Grounding stabilizes voltage. 2 different systems, 1 safe installation. That's your full breakdown of grounding electrode conductors under OESC 2024. If you want episode 3 on neutral isolation next, drop a comment and let me know. Stay safe, stay grounded. In the OESC, the grounding electrode conductor is covered under Rule 10/700, and its job is simple. It connects service equipment to the earth through an approved electrode. Now under Rule 10-10-106, the code explains why we ground systems. It stabilizes voltage, reduces the effect of lighting, and gives your entire electrical system a reference point to Earth. But look at this. The GEC is not used for tripping breakers. That's in line with Rule 10-208, where the main bounding jumper provides the low impedance false path. That's why fault current doesn't go down the GEC. It returns on the bonded neutral. The grounded electrode system is not intended to carry fault current or trip breakers. Its function is simple. It's to stabilize system voltage, reduce lightning damage, and connect electrical system to Earth. OESC Rule 10-106 System Grounding. This rule describes why grounding, including the GESC, is required. 10-1006 Electrical system shall be grounded to limit voltage imposed by lightning or line surges and to provide reference to Earth. OESC Rule 10-700 Grounding electrode conductors. This was rewritten in the 2021 and 2024 edition. 10-700 A grounded electrode conductor shall connect the service equipment to the grounding electrode. OESC Rule 10-702 What electrodes are allowed. Ground rods, ground plate, concrete encased electrode, structural steel. OESC Rule 10-208 Main bounding jumper. This is why the electrode does not trip breakers. Fault current through the MBJ, not the GEC. OESC Rule 10-208 and 10-210. The system bounding jumper bounding screw scrap must be installed at the first point of disconnection. Downstream equipment must not bond the neutral again. Neutral bars in sub-panels must be isolated. OESC Rule 10-08 requires the neutral to be bounded at the service disconnect only. This is the main bounding point. After this, every panel must have the neutral floating. OESC Rule 10-700 to 10-702 GEC must connect to the grounding electrode, rod, plate, building, steel, rebar. Must be installed continuously without splices, unless in reversible compression. Size based on service conductor size. According to Rule 10-700, the GEC must run continuously to the electrode. You can't cut, twist, or join it unless it's an irreversible connector. OESC Rule 10-700, 10-704, 10-706. Ground rods must be 5/8 diameter minimum. Ground plates must have 0.2 meters square exposed surface area. Electrodes must be connected together if more than one is used. Rule 10-704 clarifies that ground rods and plates can be used, but they must meet the minimum sizing. A plate needs 0.2 square meters of exposed surface area. OESC Rule 10-106 intent. The JSC does not clear faults. The bounding conductor clear faults. JSC job is stabilizing systems voltage and reducing lightning effects. As per Rule 10-106, the purpose of grounding is not to trip breakers, but clearing happens through the bounding conductor. OESC Rule 10-406 and 10-414 must be low impedance, must be sized according to Table 16, must connect all non-current carrying metal parts. Rule 10-406 reminds us the bounding conductor acts like a fault lane, providing the low impedance path that trips the breaker instantly. OESC Rule 10-208.
Again, as you can, please and thank you. Don't forget to like up the live stream, very important. And we have in today's quick live is I'm going to be installing a 100 amp sub panel. Reason being is the main panel is going to be filled up. So, and I'm going to have a lot of arc faults instead of the main panel. So I'm going to transfer a lot of my circuits, my smaller circuits into this sub panel. It's a 100 amp Siemens panel. I'm going to also be removing this stuff here from the panel. So at a later time, you'll see a full video of the full installation of the panel. These are my ground wires that I have installed. As you can see, I have them neatly separated. Whatever wires I have on this side, I'm going to go on to this side with my main wires, ground wires. So this is the ground bar that I'm going to be using right here. These are going to all pick up the grounding wires. Same thing on this side here. These are all going to pick up the grounding wires on this side. This here is going to be the main compartment where I'm going to be using. This is going to be my breaker that I'm going to be using to power up this eventually. And we're going to have a couple of breakers. Again, these are all 20 amps. So I always try to maintain that one side is going to be loaded properly. So I have 20 amps. I'm going to mix and match a couple 15s, couple 15s and 20s. If I have to do any 30 amp two pole, I'm going to land them on this side evenly, one on each side. Also, again, don't forget, I'm going live later on tonight, 9 p.m. It's going to be about the code. So again, for all those who are tuning into the live stream today, you can catch me live tonight, 9 p.m. About the Canadian code book. You can post your questions in the comment section if you have any, and we'll go from there. So this is my 15 amp Siemens breaker. Always remember to make sure to use the same breaker as the panel. As you can see, it's a 15 amp Siemens. Okay, and that's the name of the panel. It's a Siemens 100 amp panel. So whatever I have in here that I have to use, they're all going to correspond with the Siemens. As you can see, the label is right here. Everything is here. You know that this is approved. Again, this is bought. You have the stamp here, okay, directly from the store. We also have some other writings here, as you can see. So when it comes to the breakers, they're filled with info, and you know, I'm going to again, this is a 15 amp breaker, and how I'm going to install it, I'm going to simply position that like that, and I'm going to push this down. Always make sure that it's level. So a lot of times when this happens, okay, what I normally do that I find with the Siemens breakers is I loosen it up a little. Okay, and That's normally how I install my breakers. Pav, harmony, Jesus Christ, please be careful around those cables. Yes, it's not live. Like I said, this is a sub panel, nothing live. Okay. So again, these wires up here are all going down into here. So this panel, as you can all see, is not live. Um, the main compartment is going to be up here. So again, there's nothing live on this panel. Again, as you guys come in, please don't forget to like up um, and thank you. Helps YouTube to push my videos out into the algorithm a lot more. So this is another 15 amp breaker I'm going to be installing. Same thing, Siemens brand. Okay, and then you have my grounding here that I'm going to be positioning properly when it comes to grounding off the cables. As you can see, I'm all positioning my wires in the same location. Again, thank you for the support. Here's for good luck. PRVT Haruma. Again, thank you for the donation towards the channel. And again, also don't forget to, you can catch my live later on in the evening tonight around 9 o'clock, where I go fully in depth into the code and why the code book is used and why it exists. It simply exists for reasons like this. Ground wire. I'm going to be going on to the grounding bar. Okay. So watch the way I position my ground. I shape it when it comes to the panel. I try to stay away from this compartment here. That's going to be livened up eventually. So what I mostly do is I try to get my grounding wires all the way over, tucked the way over into the corner. So also with the holes that you're going to be seeing by code, I have to make sure that these holes are covered up. This is an old panel, not an old panel, but this was used for temporary power. With the panel itself, it's all intact. So for that reason, I'm going to be using it inside of the home instead of throwing it out into the pile of garbage. There's nothing wrong with it. It's just used for temporary. Um, Also, when it comes to the panel, so again, this is my face plate here that's going to go onto there once I remove these wires from here. So it looks like that is reamed out. So I'm going to somehow have to get this off or take this up in order to remove, to remove this from here. Um,
So these are my Allen keys that I normally travel with. Never forget your Allen keys. There's many sets that I have here. I also have this set of Allen keys that I use for the bigger stuff. Comes in handy. Um, as you can see, I tried with these Allen keys the first time, didn't work. So I simply went to the other set of Allen keys. A lot of times I also use this set of Allen key for the main service when it comes to the outdoor meter bases and stuff like that. It helps with the turning of the wrist. A lot of times when we go to do the service upgrade, it ends up being that sometimes the lug is stuck and you need something a little bit more stronger. I inherited this from one of the crews that I was working with when it came to doing a service upgrade. And it's one of the tools that I normally travel with. Make sure it's in my bag with the material that I need. It's very with the tools that I need. Sorry, very handy. We're going to remove this from here. As I said, I don't need that. And we're going to be removing this. So in a normal situation like this, if I was coming in with my main wires, over here we have the grounding onto the metal casing of the panel. Up here we have our bounding. This is basically the wire that comes from underneath the ground. You'll see it in some of my videos where ground where I have my ground plate inside of the ground. Usually when that comes up out of the ground, we come into the panel and we're going to install it here. However, for this type of setup, I'm not going to be using this because once I come from the main panel, I don't need a bounding. It's already bounded through the set of cables that I'm going to be using. So I'm going to be removing this. Also, another thing that I'm going to be removing from this panel is my bounding strap, as I don't need it. So these are again another handy tool to have. Big, gets the job done. So for all those who are wondering, this is the bounding strap that I'm going to be removing. And I'm simply going to tuck this screw back into the panel. So again, as you guys come in, don't forget to like up the live. Helps my channel to go out into the YouTube algorithm faster. Um, so that's what we have here. Again, as you guys come in, also for those who are tuned into today's live stream, who are watching the live stream, I'm going to be going live tonight on the full breakdown of the Canadian Electrical Code and try to break down the international code book, as there's probably not too much of a difference. You can join me tonight, catch the live at 9 p.m. tonight when I go fully in depth into the code book. So again, that was the bounding strap that I removed. I don't need that bounding strap. So I'm going to take this out of here. Um, so we've completed the grounding. We've went over the bounding, how it goes. So my new cable that I'm going to be feeding into this panel, I'm going to be grounding off this panel. I'm going to use my ground wire and I'm going to ground it here. I'm not going to be going on to here. As I said, this panel is going to be already bonded through the main panel. So it doesn't require you to actually bond it again. Actually, it's in the code book. For those who wants to double check, you can. And again, these are my white cables that I'm going to be using.
Since I've already tied in my grounds, next thing you do is you simply go and you tie in your neutral cables. So again, hello and welcome back to the channel. You guys are tuned into Fabian Electrical Services. I'd like to thank you guys all for tuning into today's quick live stream. Before I go live tonight, again, I'm going to be going live, so you can catch me live tonight at 9 p.m. So always remember, when right now I'm using my pliers to strip the cable. There's a certain way that we use that in order to not damage the end of the cable. Another tool that I like to use is, you can see it's insulated. Helps with when the panel is live. If we have to do a quick job, you can touch around here. You can touch around the breaker. Again, this is not live, but this is another great tool that I like to have on me when it comes to cutting in my cable when I have to install a quick service call. It helps with the knowing that it is insulated. You always try to keep your maintain that you're working live, even if you're not working live. It's a code, it's a rule that we've always followed throughout our years. So right now I'm treating this panel as though it's live, but it's not live. Always try to do a little bit of what you need. You simply go with the momentum. Make sure that this wire is not broken, and you're good to go to install. So again, these cables are all not going to be on an arc fault. That's why I'm landing these cables right now. Eventually, I'm going to be transferring from one end to the other, from the other panel to over to this panel. So I will have some arc faults here.
So again, welcome back to the channel. You're tuned into Fabian Electrical Services. Again, I'd like to thank you guys all for tuning into today's live stream. So what we're doing is grounding and bounding. Basically, where I do my bonding here when it comes to my main panel inside of the home. However, I'm not going to be bonding today because this is the sub panel. The main panel is already bonded, so I don't need to pick that up twice. Also, I'm going to take my bonding strap, which is here. I'm going to remove that from my panel and tuck it to the side. I don't need that either. Again, also, when it comes to your breaker, this is a Siemens panel. Sorry, this is a 100 amp Siemens panel. This is the main compartment where it's going to be landed. After once it's landed, I'm simply going to be using this cover here to place it. And the marking that we're always looking for to make sure that it is labeled accordingly. There's another marking that we have to look for when it comes to the safety installing the panel, and it's called this right here. Once the inspector comes, he's going to be looking for this symbol right here. Symbol clarifies that I can use this panel. Simply, when, for instance, when I was doing the my first panel here, I missed it. The panel cover didn't have the information on here. I'm not sure, randomly happens. And I needed to bring the panel cover back to the supplier in order to have this sticker so I can have the inspection pass. So very important. This is a key part of your installation. Key part of your inspection is to always make sure that this here is what you're looking for when it comes to the installation of a new panel. If you don't have this here, if this market is up on the panel cover here, comes to the that I just had a call. So when you want to be looking for your breakers and what you need to use, you're going to this is what you're going to looking for. It has the information here. Very important to make sure that when it comes to the code, you have this information on the cover of the panel. It's going to give you the list of names of breakers that you're allowed to use inside of the panel, which a lot of us are not aware of. So also, like I said, for all those who are tuned in into today's live stream, I will be going live tonight. So please, you guys can come out and join the live tonight. It's going to be fully in depth into the code book. You're probably also going to see a replay of this video explaining what's going on here with the grounding and bounding. Also, you're going to see me explaining one more time past all miss the live stream. As you can see here, times what happens is there's a Eaton breaker. It looks the same. Again, this is the Eaton breaker, and a lot of times what happens is sometimes we'll end up seeing these different types of breakers inside of the panel, and it does look similar. As you can see, it does look the same. There are two different names that we have here. For this reason, this will fit into the panel.
However, when it comes to your final inspection, you cannot have a Eaton breaker instead of a Siemens breaker, a Eaton breaker instead of a Eaton Siemens panel, or you cannot have a Siemens breaker instead of a Eaton panel, vice versa. The inspector is not going to pass the job. And also, as you can see, previously explained, these are the names of the breakers that we can use inside of the panel. So anything that correspond with these names here, Siemens, we can use inside of the Siemens panel. The way how I position this is, as you can see, this is where the blade is going to go onto the panel. This is where it's going to go onto the back of the panel. I kind of do it like that and push it down. So as you can see, it's lifted, and I'm going to install my so what I've got here is this is my 30 amp dryer cable. As we all know, when it comes to the dryer cable, we have to have 2 hots and 1 neutral. So these are my 2 hots I'm going to be tying on to a 2-pole breaker eventually. And again, had previously discussed in the first part of the live stream, when it comes to the breakers, always maintain loading your panel properly. When I say loading each side properly, I mean this is a 20 amp, this is a 20 amp, this is a 20 amp. These are 15s. Eventually, I'm going to put a couple 15s here. I'm going to put a couple 20s here. Also, if I have 2 double pole 40 amps, I'm going to place one on this side, and I'm going to place another double pole 40 on this side. It helps with the balancing of the panel. And when I say balancing of the panel, it helps to balance out each side properly. You don't want to have one side overloaded and the other side off. It's going to eventually give you problems when you start to work the panel. So for that reason, we try to load the panel as properly as we can. It is part of the code. Also, when it comes to this panel, I'm going to have to leave a couple spaces open for future, either this panel or the main compartment. I have to the panel free up for space just in case there is work that's going to happen in the future. I cannot load this entire panel and load the main panel and don't have nothing to play around with. I'm not going to have the inspection at the final. Also, I do not need all of this. This is too excessive, so I'm going to be trimming it down to what I need. And voila, that's basically how you install your grounding. As you can see, I have my ground wires tucked behind. I want to make sure that my ground wires are tucked behind. I don't want them to come in contact with the live compartment once I liven up the panel. So again, this was just a quick live stream for all those who tuned into the live stream. I would like to thank you guys all for tuning in to today's live stream. And you can catch me live tonight. Uh, Live. I'm going live tonight at 9 o'clock p.m. in the evening. Uh, it's going to be a full in depth on the code book and how I go about using the code book, and I explain a little bit more into the code with the rules. So don't forget to join the live stream. You can leave a comment in the comment section telling me what you talked about this live stream, or you can catch me live and leave a comment asking any questions you have to ask about the electrical code book. And again, I'd like to thank you guys all for tuning into today's live stream. This was a quick live stream on grounding and bonding that was explained. Again, before I go, I'll explain it again. Grounding and bonding. This is basically my grounding here that I'm doing. Okay, that's what's called grounding. When it comes to bonding, we simply use this part of the panel instead of the main compartment. We bring in our bond wire from the underground onto the ground plate, and we're going to bond this panel. However, this is not a normal situation. This is a sub panel. The bonding inside of this home happened at the main disconnect. For all those who missed that, you can catch the replays on some of my last current live streams where you will see that. Um, that's where the bonding happened. So I don't need to bond this panel. I also need to remove my bonding strap. That's what I've done. And you have the breakers that you have to maintain the same breakers being used instead of your Siemens 100 amp Siemens panel. These are all Siemens breakers. Okay. Also, you have to make sure that when you are going to be buying a panel, you make sure that you're looking for the label that's here. You make sure that you're looking for the SA symbol here, which is going to be allowed for ESA inspection. And again, you have here the marking of the breakers that you can use for this panel. It's going to be filled with lots of information. So again, you just have to look and make sure that you find the proper information. And voila, again, when it comes to another um, electrical code, um, Canadian Electrical Code 2024, I have to maintain these holes. I have to close them back up. Also, I have to close this hole back up. And that's it for today's live stream. So I'd like to thank PRVT Haruma for checking into the live stream, and also for sending a donation towards the channel. And again, I'm going live tonight, 9 p.m. in depth into the 2024 code book, also the changes I'm going to be going into, and also I'm going to be going into the hazards that happens on the job site. I'm also going to be going into a little bit more of why we size wires the way we do. So it's going to be a full in-depth you can leave a comment in the comment section. You can leave a question if you have any questions. You can also join the channel, Fabian Electrical Services, and support the movement as I'm trying to have the channel go into the algorithm to get further into the YouTube world, as it's taking a little bit of time here to get out into the YouTube algorithm. So again, just join the live tonight, and I'll catch you guys on the next live.